So it's February 5th of 2022. We graduated in May, and we have to make a little video update about what progress we've made since our video that we made at the end of last semester. So that's what this video is for. So starting off, this is going to be mentioned a little bit later by Luis, but we did get the PWM capabilities of this working. We were kind of freaking out about it last semester because we realized late in the game that the Jetson that we're using didn't actually have PWM on it. So we had to use a third-party PWM controller, and again, Luis will mention that a little bit later. Next up, we got a simple socket program working, just using Wi-Fi communication with the computer, where we can either use a 5-button UI or just the WASD arrow keys on the computer to send drive commands to the robot and let it drive around on the floor. And then last of all, one thing that was really giving us some trouble was the camera. So the camera is using NVIDIA's inference libraries in Python, but all the example code was written in Python 2.7, whereas our stuff is in Python 3. So we had to go through and basically rewrite all of our stuff in Python 3, and we did get the camera working. It can print out the exact middle location of any person that it sees in its field of view. And then also more recently, we got a little example program working that we actually just wrote that will try to track a person and turn to always be pointed directly at them. Now that's kind of the exact opposite of what a robot actually has to do. So basically, once we have that working, which it is now, we just tell it to do the exact opposite of that. Instead of pointing at the humans, avoid them.
So far, we've implemented the GPS sensor, which is the ZED F9P, into our robot system. What that means is that with the GPS sensor hooked up over I2C into an Arduino, we can then output the GPS location through serial over to our Jetson Nano. So our GPS sensor has a 10 millimeter accuracy, and then outside of that, the Arduino program only allows for every 1 second for the refresh rate of the GPS sensor's information. So if we were to do anything faster than that, then unfortunately we'd just be getting the same value over and over again in between the 1 second intervals. So we actually have a magnetometer coming in, we've already ordered, and we plan to implement that. So with the GPS sensor, we're only able to get positional accuracy, but we're not able to get the direction of the robot, and this magnetometer will allow us to have a little bit more information on where the robot is headed and which direction it's pointing.
Next up, we have our motors. Last semester we weren't able to get our robot to move, but this semester we have been able to improve and have been able to connect our motors to our REV Sparks motor controller and our PC9685 connected to our Jetson, which we then wrote code to get the motors to move. We also created a very basic chassis out of wood for at the moment, but right now it's really unstable and things like the motor can move really easily, and it makes it unable for us to move the robot around as easily as we want it to be. But we did actually, in fact, create a draft chassis made out of wood right now. Right now our current plan is to make it look something like this, but we are going to change the wood into aluminum. And then after we finish the aluminum part, we will be adding the 3D printed parts to make it look a little bit more comfortable to the eye for people.
As you can see, I've been sitting here working on the battery pack for the last couple of weeks. We have got a total of 24 batteries in an 8 parallel 3 series configuration, which means in total for the 3.5 volts we have across each 18650, we're going to stack to 10.5 volts. Along with that, we've got our battery management system. So right now, this may just appear as a PC board, but once this is electrically connected here, it's going to make sure we have overcurrent protection, kind of similar to what we have on our DC power supplies, to make sure that nothing goes boom. The next big point for us as far as like how to be electrically intelligent was on the battery itself. How do we make sure that we have 5 volts across our sensitive electronics and not the 12 volt behemoth battery that you see here in front of you? Stepping that down was a really big part of making this design process work.